Solving quadratic equations by graphs and factoring, okay? For the record, today we're mostly just going to deal with graphs, okay? We'll get to factoring eventually. We're going to use this worksheet for a couple days, okay? So let's start off by looking at the top. Consider the equation x squared minus 8x plus 15 equals 0, and show numerically that x equals 5 is a solution. Okay? How are we going to show numerically that x equals 5 is a solution? Okay? Hey, can we use our big kid math words? What's the big kid math word? Substitute, right? Substitute the 5 in for x. 5 squared minus 8 times 5 plus 15 equals 0. Anybody know what 5 squared is? Excellent. 25 minus 40 plus 15 equals 0. What is 25 minus 40? Negative 15 plus 15. Is that the only way I could do that problem? Okay, just something to think about. There's also another solution to this equation though. So let's use the table to help us figure out the second answer. We are preAP, yes? Okay, it sounds like I'm saying we are Borg. I'm not. I'm just saying we are preAP students together as a class, but not we because I'm not really a preAP student, but whatever. We are going to not get bogged down with the arithmetic, which is what they want us to do in each section right here. They want us to say 1 squared minus 8 times 1 plus 15. We're going to let the calculator do the work for us because I also need you to understand that that's what the calculator does for us. Okay, so we're going to go to a graph. Whatever's in there before, go and take it out, and let's put in our equation x squared minus 8x plus 15, and let's go look at the table. Yes? Okay, I need you to understand that what the calculator is doing with these x values is substituting it into the equation to give you the output, give you the y values. Are you okay with that? Okay, so 1 is 8, 2 is 3, 3 is 0, 4 is negative 1, 5 is 0, 6 is 3. Okay? So this just says, is this a solution? Is 1 a solution? Well, how are we going to know if it's a solution or not? How do we know 5 was a solution? Because it equaled 0. What is it asking us to find? Something that equals 0, right? So is x equals 1 a solution? Because it equals 8. It doesn't equal 0. Okay? Is 2 a solution? No. Is 3 a solution? Why? Because it equals 0. 4, is 4 a solution? What about 6? No. Okay? So here's a solution, and here's a solution, right? Using the table above, plot the points on the graph to sketch the function. Okay? 1, 2, 3, 4, 5, 6, 7, 8. 2, 1, 2, 3, 3, 0, 4, negative 1, 5, 0, 6, 3. No, not right now. Whoops. Okay, is it plotted? Do you have what I have? Did you do that, or did you stop at this dot? Should it stop at this dot? No, it shouldn't, right? You know it goes on. Just didn't have that many points on the table. Okay? Which 2 points represent the solution to the original equation? 3, 0 and 5, 0. Where are both of these points located? On the x-axis. Why? Why? They're equal to y equals 0? Can you explain that a little bit more? It's not wrong, it's just confusing. Anybody? We're finding when y equals 0, right? That's what we said at the very beginning. When y equals 0, these 2 points have their y values equal to 0. Okay? Their x value is what gives us the value that worked in this equation. By worked, what do I mean? It solved for 0. Okay? What x value will give you 0? And that's the x value that gives us 0. Both of them, in fact. Okay? Any questions? Okay. I alluded to this a little bit yesterday, but I want to go ahead and really focus on it today and get it taken care of. There's different names for these things. Remember? What were we calling them yesterday? Do you remember? Like solutions, right? But when we use the calculator to go find where it crossed the x-axis, what did we have to look for? 0. Okay? Those are 2 different things, but they're kind of the same things. Here's what I mean. When we're dealing with this type of general equation, there's only x's, right? No y's. There's only one variable in this equation. The answers are called solutions, which is what we called them yesterday, or what? Roots. Why are they also called roots? I have no idea either. Okay? Maybe it's like where a tree grows up from the ground and right where the tree is at is the roots. I don't know. I totally made that up right now. Okay? That's just what they're called, and we have to be ready for that. Okay? That's just a definition you need to know. Okay? When we're dealing with functions, however, how is this different from this? How is it different? There's 2 variables, right? It's y equals, not equals 0. All right, sorry about that. Tell me the difference between these 2 things. It says 2 variables, right? This equals 0 and this equals y. Okay? We're clearly graphing this one because it's 2 variables. Here we're just solving, right? Okay? But we're solving this one too, but whatever. We'll get to that later. The answers over here are called zeros, like we talked about yesterday, but what are they? What's an obvious thing we could call them? X-intercepts, right? We talked about that even up here, okay? Now, if you didn't understand it the first time when I said obviously, I apologize for that. I was not trying to call you stupid for not realizing it, okay? I just meant the obvious thing that these points right here are called, not the answer to the blank. Sorry. Okay? Any questions about that? This is just some definitions. You'll need it for your homework for sure, though. Okay? So we're just focusing on graphs today. Okay? Just focusing on graphs today. So, let's look at this page. Use a graphing calculator to complete the chart. Well, you all have your graphing calculator, correct? So let's complete the chart. First thing it asks us to do is it gives us a factored equation. It asks for the expanded equation. How did they get the expanded equation? They multiplied it out, right? Okay. Then they sketched a graph. Where did the graph come from? Probably graphing calculator. The zeros of the function, where did that come from? From the graphing calculator. And where are we going to look for these? The x-intercepts. And then we check with the table. Okay. Chances are, what is that point right there? The vertex. Okay. Chances are it's going to be the vertex. If it's possible, I would like your vertex in the middle and your x-intercepts on either side. Or unless the x-intercepts are on the same side of the vertex, that doesn't make sense. They're on the same side. I don't know what I'm trying to say. You know what I'm trying to say, right? Okay. Get your vertex in the middle, put your intercepts on either side of it. Fair enough? Okay. So let's try number 1 together. Here's the factored equation. How much work do I need to show on this for you guys? 0 work. So I can go straight here. Y equals x squared minus 3x minus 4. You got that? Because remember, for those of you who don't, just to make sure, I got it by plus 1x minus 4x. That gives me minus 3x. Everything else is just the distributive property, right? Okay. So in your calculator, hopefully you've gone to put this equation, either one of these equations actually, into your tab at the top. Yes? So like mine looks like this. Does yours look like this? Yes or no? Okay. So let's see right there. And there. And something like that. Now, how careful was I when I do that graph? Not very, but I know where it crosses the axis, don't I? And those are the solutions I'm trying to find. That's really what I'm focused on right now. We already did a section about quadratics, about can you graph a quadratic. And we'll do more if we need to. That's just not our focus right now. Okay? Fair enough? So what are my zeros? Excuse me. What are my zeros? X equals -1. X equals 4. Wait a second. How do my zeros and my factors relate again? Did you just figure it out? Good. I saw the light bulb. How are they related? Now, I want you to be careful. If you'll remember back what I told you yesterday, you take the factors and set them equal to 0, right? You remember that? And some of you thought to yourself, I'm just going to think it's the opposite, like +1, -1, -4, +4. That's safe sometimes. Remember that you got to set them equal to 0 is safe every time. Okay? And I'll show you an example here in just a moment. Actually, let's do it right now, because we're on the topic. Look at number 5. Number 5. Ooh, number 5's different. It gives me the expanded equation and wants the factored equation. So what do I have to do? Factor it, right? How do I factor this equation? Well, I got to find AC. What's AC? -24. And what's B? 5. So what multiplies to be -24 and adds to be 5? (8x) and -3x, right? I heard one person say it. I didn't hear anybody else though, so I need to make sure you guys are good. Yes? Okay. So from here, I just look at the first two. Factor out of 2x. What's left? x plus 4. Just look at the second two. What do I factor out? Negative 3. What's left? X plus 4. So what's my factored equation? Y equals what? 2x minus 3 and x plus 4. Okay. I'm going to jump right over here because this is what we've been talking about. What are my zeros? For sure, negative 4, right? And I heard somebody say 3. Just because you took the opposite of that? Because remember I told you that doesn't work all the time. This is the exact case where it doesn't work. What I have to do is set this equal to 0. I add 3 to both sides, which gives me 2x equals 3. Then I just have to solve for x. So what is the 0? It's not 3. It's what? 1.5. 3 divided by 2, right? Questions? I just need to let it sink in for a minute. All right, we need to talk about number 3. What is the expanded equation on number 3? Good. Good. Minus 10x plus 25. Because if I distribute, I get a negative 5x and a negative 5x. That gives me negative 10x, right? Okay. So when I go to graph it, I want to show you what this looks like in the calculator. God bless you. See what it looks like? What's happening? Yeah, that's the only place, right? The only place where it crosses the x-axis is right at 5. So what are the zeros of the function? What? X equals 5? Okay, I'm going to skip ahead. We're going to come back, but I'm going to skip ahead. We have to have this conversation now. The fundamental theorem of algebra states that a polynomial equation of degree n has precisely n complex roots. What's the degree of a quadratic equation? What's the highest exponent of a quadratic equation? 2. How many complex roots should it have? 2. Look at these possibilities. Do you see that all 3 of these are possibilities for a quadratic? And obviously it can be opening up or down, okay? And have these things happen as well. How many roots does this have? Obviously 2 complex. First of all, obviously because it says, right? And second of all, that's what we just talked about right up here. This, how many times does it cross the x-axis? Twice. This has 2 real roots. Why does it have 2 real roots? Crosses the x-axis twice. How many roots does this one have? How many roots does it have? 2 complex, but 1 real. How many answers should it have? How many roots should it have? 2. This has 1 real double root. Why? Why does it have a double root? It has 2 real roots, but they are the same. Just like problem number 3 that we just did, right? Isn't this what's happening? It's sitting right on top of the x-axis. Okay? When we write our factors, first of all, our root is x equal 5. That's where it crosses the x-axis. But when I write my factors, I have to remember that this is a double root. I should have two factors. And then that's my expanded function. Does that make sense? Okay. Why does it have one real double root? Crosses the x-axis in one place. Yes? Okay. And what about this last one? No real solutions. Or roots, yes. Why? Doesn't cross the x-axis. Okay? Any questions about that? Already have it? Okay. Let's jump back up to the top of the page real quick and answer a couple questions up here. How is each factored equation related to the zeros? We talked about it. I want to get written down. How is the factored equation related to the zeros? Set the factors equal to 0. Good. Now that's really an unfinished sentence, isn't it? Set the factors equal to 0, and then what do you get? The zeros. Okay. Look at number 8. Equation 3 uses the same factor twice. How does this affect the graph? It's only one real root, and it touches the graph only in one place. Okay? You got that? Okay. Look at the next page at the sample problems. Look at problem number 1. Complete the table to determine the zeros of each quadratic function. If we complete the table, what are we going to actually find? Are we going to find the x-intercepts? So we have to know the difference in how to write the x-intercepts and how to write the zeros, don't we? Okay? For that reason, we're going to do F first, and then we'll go back and do A. All right? The zeros of this function are here and here, correct? Which would make them 1, 2, 3, x equals -3, and x equals 2. Okay? So that's how we write our zeros. How do we write our factors? That's an x-intercept. You guys are telling me great answers for x-intercept. How do I write my factors? Yeah, look back over at the chart. What do factors look like? So x plus 3 and x minus 2. Excellent. So how do I write the function? X squared plus x minus 6. X squared minus 2x plus 3x, which would give me x minus 6. Right? Okay. So now go back up here to the table. X squared minus 2x minus 3 gives me a table that looks like this. So I need to transfer this table information onto my table on my paper. 5, 0, -3, -4, -3, 0, 5. What is a 0? X equal -1. Is there another 0? What is it? X equals 3. Okay? Any questions about how to do those? Alright, then let's look at C. How do I do C? Well, use a calculator to sketch the graph. -1, and +5. Once again, if I'm graphing to solve, I need to be careful how I graph, don't I? What are my x-intercepts? Am I going to write x equals -1? Yeah, it's an x-intercept. That's a point. So -1, 0. Does it have another x-intercept? 5, 0. Any questions about those? Okay. Turn to the very back page. 1, 2, 3, 4. Those are the 4 I need you to do between now and class tomorrow. Okay? 1 through 4. Any questions? Peace.